Question number 4 in section 3.1 quadratic functions asks you to graph the following on the same coordinate system. And you have all these variations of our basic y equals x squared or the parabola. So one thing, hopefully you recall from the previous chapter about how we looked at parabolas and all the different ways that you can affect the shape of the graph, that this should come in pretty handy. For example, you can make a table of values, although I don't, hopefully you're not relying on this late in the semester, but if you need to, for example, you would plot a couple points, 0, -1, and +1. And you're looking at plugging those into the function y is equal to 2x squared. Plugging in -1 and squaring it, and then multiplying by 2, you get 2. Plug in 0, you get 0. Plug in 1, you get 2. And then you can plot those 3 points. -1, 2 is a point, 0, 0, 1, 2 is a point. So we have this graph right here. And we can select that from the ones given. But it does look most like choice B, but I'll zoom in just to be sure you have the point 1, 2, 0, 0, and -1, 2. I'm going to choose that and check the answer. Now for part B, we want to graph y equals 9x squared. So after you square it, you're going to multiply by 9. So imagine what's going to happen to those graphs, the graph, as we have 9x squared. I'll do that one using the red table of values here, where y is equal to 9x squared. And just plugging in those same values for x, plugging in, squaring, and then multiplying by 9, you get 9, 0, 9, and you can plug those points in. And in fact, it's going to be off the page here. It's going to be -1 all the way up to 9, 0, 0, and 1, 9. So it's going to look something like that. We can zoom in to get a better look. And out of all of those choices, it does look like the first choice. We see the y equals 2x squared graph, and then the other one, definitely more narrow graph. If you plug in -1, you get +9, so you can locate those points. I'm going to choose the first one and check the answer. Now we want to graph y equals 1/2 x squared on the same coordinate system. So you would square the number and then multiply by 1/2. Let's try that using right here. If you have y equals y equals 1/2 x squared. Just plugging in those same values. Plug in -1, 1 squared, you get 1/2. Plug in 0, you get 0. Plug in 1, you get 1/2. And that is going to make your graph look wider than the previous two. And out of all of those choices for part C, it does look like the second one gives you the original one, the 9x squared, and the 1/2 x squared. You see the 1/2 x squared is wider than the previous two. And then we want to graph 1/9 x squared as our final graph. We can also make a table of values. If x and y, which is equal to 1/9 x squared. You can plug in values like -1, you get 1/9. Plug in 0, you get 0. Plug in 1, you get 1/9. So that really ends up making it much, much wider. So out of all the ones we have the choices for, it does appear that we have the original one in blue, the 2x squared, and the 9x squared is very narrow, the 1/2 is the red, and then the widest one is 1/9. I'm going to choose the first one and check my answer and continue. Now, how does the coefficient of x squared affect the shape of the graph? Well, the one that was the most narrow graph had the 9 in front. That was a really large number, 9, which made a very, very narrow graph. And the one that was the widest was 1 over 9. That's a very small number, close to 0. We see that it was very wide, and even the half was wide. But the most narrow one was the 9, so it really looks like the larger that coefficient is, the more narrow the graph is. And the closer that coefficient is to 0, then it looks like it's going to be the widest. So out of all of the choices given here, okay, it's definitely not moving it to the right or left, so we can eliminate that choice. It does make it either wider or narrower. They're using broader or narrower. If the absolute value is greater than 1, it does make the graph narrower. If it's less than 1, it does make it broader or wider. So I would say out of all these choices, B is the correct answer. All right, let's go on to number 5. Okay, this is a similar kind of problem where we're starting off graphing y equals x minus 1 squared, then x plus 2 squared, and x plus 9 squared, and we want to graph those all in the same coordinate system. So we're looking for the relationship um, with these minus 1s plus 2, how that affects the shape of the graph. Now again, if you recall from the previous chapter, this is a basic parabola that's been transformed. When you're graphing the first one, where you have y equals x minus 1 squared, this is a parabola that has been shifted to the right 1 unit. So where your normal vertex would be at 0, 0, this vertex has been shifted to the right 1. Again, you can also make a table of values. I usually choose a vertex and a point to the left or to the right. So if I chose 0, 1, and 2, plug those in for x, you would get 1, 0, and 1, and that would correspond to the 3 points that I've graphed here. So it is a parabola that's been shifted to the right 1 unit. I'm going to have to zoom in to see. It looks like the last choice here is a parabola that's been shifted to the right 1 unit. Now we want to graph the second one, which is y is equal to x plus 2 squared. Again, if you're familiar with those transformations that we studied in the previous chapter, this graph has been transformed by moving the basic parabola graph to the left 2 units so that the vertex is right here at negative 2. So you can plug in a few values if you wanted to confirm negative 3, negative 2, negative 1 as your x values, and plug those in. You would get 1, 0, 1. So you would see those are the points. So that parabola has been transformed by shifting it to the left 2 units. So we want to look at which of these correspond. Zooming in, it looks like possibly, let's zoom into this. Yes, this one looks like the light blue one has been shifted by moving to the right one, and the second one shifted over to the left 2 units, because these units are broken down by 2's. So it looks like I'm going to choose this one. Okay, now that plus 9, choice C, we want to graph the y equals x plus 9 quantity squared. So again, you can make another table of values, but by understanding those transformations, this is our basic parabola graph with that plus 9, meaning that the whole graph has been shifted to the left 9 units. So way over here, kind of off my graph square here. The whole thing has been shifted to the right, left 9 units. So that it looks something like this. I apologize for the messy graph, but this graph has been shifted. And if I zoom in, it does look most like this one here. Shifted over 2, 4, 6, 8, 9. The x plus 9 means the whole graph has been shifted to the left 9 units. You could also make a table of values and check your work. I would choose points such as, I would choose maybe -10, -9, and -8, and find those corresponding y values to make the decision. And then I believe there's one more graph to make, and that is y equals x minus 5 quantity squared. Let's do something. Clean this up a little bit. Alright, so we're graphing y equals x minus 5 quantity squared. That minus 5 means that the basic parabola has been shifted to the right 5 units. So that graph, 1, 2, 3, 4, 5, is going to be a graph that has been shifted to the right 5 units, opening up. And I believe they have it graphed in purple here. So the light blue is the original, the dark blue is part B, this plus 9 is in red, and the minus 5 is in purple. So you see it has been shifted to the right 5 units. And that looks most like the second choice for me. And then finally, the last part of this is to interpret this. We say that this minus h, whenever it was a minus h, it shifted to the right h units. Okay, let's double check here. Okay, so we can eliminate choice A and choice C because those involved shifting the graph up or down. These graphs are definitely shifted to the right or left. The graphs are shifted to the right h units if h is positive. Now there is a minus sign, so if x minus 1, the 1 is h and 1 is positive. So choice B, I'm going to check that is the correct answer.